Today we will talk about straightening the graph. Before we explain on how to straighten the graph, we will talk a bit about the equation of the straight line. The form in which the equation of the straight line we work mostly on physics is the slope and y-intercept form. In this form, y is equal to mx plus b. M is the slope, so whatever is the horizontal, the variable in the horizontal axis multiplied by is the slope of the graph, and b is the y-intercept. Now, in a normal x and y axis, what you have seen even in math, you will see something like this, where this one here is the value of b, and the slope is delta y over delta x. This slope can be positive, like in this case here, when the graph is straight up. It can be negative when the graph is falling down, quote unquote. So when you have something like this, or it can be zero when it is parallel with the horizontal axis. So it's either this one or this one here. Now, how do we calculate the slope? We have done this video. You can refer it to it and see on how to. So we have done the video on how to manipulate the equation of the straight line, in which we are finding the slope, y-intercept, writing the equation of the straight line, and then if we know the value of x, how to find the value of y. If we know the value of y, how to find the value of x. So this is in a total separate video, which you can watch on your own. Now, if we bring again y is equal to mx plus b, which is the equation of the straight line, the y value is, or what the y quantity is in the vertical axis, and x quantity will be in the horizontal axis. Now, x, or the horizontal, is corresponding to that is known as the manipulated variable. How do we find which one is the manipulated variable in an experiment that we are doing? This being an experiment that we are doing on our own, or an experiment that we read that someone else did. The question that answer the way that we find a manipulated variable is by asking the question, what are you changing on the experiment? So if you are changing the distance, then that will be the manipulated variable. That or something like that. And whatever is in the y or in the vertical axis is that is known as the responding variable. And that variable is found by asking the question, what are you measuring in the experiment? We have to keep in mind that in one experiment, we should have one manipulated variable and one responding variable, meaning that we should have one variable that we change, one quantity that we change, and one quantity that we measure. We cannot have an experiment that we are changing two things. Okay, that will be a different experiment. And the rest of the variables that are part of the experiment are known as the controlled variable. And controlled variables, of course, can be more than one. Those variables through the experiment are kept constant. So now, in this contest, whatever is the manipulated variable or some form of the manipulated variables, some modified forms of the manipulated variable, and will be in the horizontal, and whatever is the responding variable or some forms of the responding variable will be part of the vertical axis. So sometimes it's just the variable in the vertical axis, and sometimes it's a manipulated form of the either manipulated variable or responding variable in the corresponding x-axis or y-axis, or in the horizontal axis and in the vertical axis. So now, this is in terms of defining which one is the manipulated variable, controlled variable, control variables, and responding variables. And then making that connection that whatever we are changing will be in the horizontal or something manipulated, and whatever we are measuring will be in the vertical axis. Let's take now a simple formula which you have seen so often on Physics 20. Let's suppose that we are having an experiment in which what we are doing is we are changing the acceleration of an object, and we are measuring the force net of the object, keeping the surface the conditions of the motion and the mass constant. So on this contest, what you are changing will be the manipulated variable. What you are measuring will be the responding variable. Okay? When you see an experiment, the very first thing is that you have to think of is what is the formula that gives me a solution to this experiment. And then in this case, the formula is force net, second law of Newton, is equal to mass times acceleration. Let's ignore the vector sign here because we know now that force net and acceleration are in the same direction. So let's release the expression from the vector conditions. Now, the key is to mirror this formula here that solves or gives a solution to the experiment with y is equal to mx plus b, which is the equation of the straight line. So what you are changing is going to be in the horizontal axis. So you will have this. And what you are measuring is going to be in your vertical axis. Now, the key here, mathematical key, is to see if the exponent or the variable is to the power of 1. If it is to the power of 1, then you have nothing, you are not doing anything. You're not manipulating it anymore. If it is, then you should manipulate it. And we will see cases like this. So on this case, you see that the responding variable is to the power of 1. The manipulated variable is to the power of 1. So you can say that in the y-axis or vertical axis, you will have force net. And in the x-axis or in the horizontal axis, you will have acceleration. Then, from here, whatever is multiplied by the x, the slope will be mass of the object, and y-intercept is equal to 0. So graph that you're expecting to be on this experiment is something like this: force net here and acceleration here, and you will see that as a straight line where the slope is equal to mass of the object and the y-intercept is equal to 0. I hope that this makes sense. Now let's see another experiment. You are measuring, so there is, supposing that there is an experiment in which you are measuring what is the universal force of gravity. What is the universal force of gravity? So this is what you are measuring. And what is the universal force of gravity between two given masses if you change the distance between the center of the masses. Masses is changed. So from here you can say that while measuring the universal force of gravity, so this will be the responding variable, and I am changing the distance between the center of the masses, and this will be my manipulated variable. The formula that relates, that gives us the relationship between the universal force of gravity and the distance and the masses is the universal force of gravity is equal to capital G mass 1 mass 2 over r squared. So our objective is to mirror this with y is equal to mx plus b. Great. Now our y is the universal force of gravity, because this is our responding variable, and our x is the distance. If you plot this as the distance, then you will not have a straight line. You should be able to realize this immediately, because you do not have r in the numerator on the top, and r is not, so two reasons, and r is not in at the power of 1, is at the power of 2. And you have seen this in physics 20, that this is squared, inverse squared direct proportion of the force and the distance. Okay, good. Now, the question will be, okay, what should I do now? So if I take this formula and rewrite it in a different form, m1, m2 times 1 over r squared. Mathematically, I'm doing nothing wrong here. I'm just multiplying two fractions, and this form is a nicer looking form. This is the same logic. Now, if I assign the whole term here as a new manipulated x, okay, as a modified manipulated variable, then I will have a relationship that is G m1 m2 times are my manipulated or modified manipulated variable. So now this, it mirrors mx plus b, where y is the universal force of gravity or vertical. My new x now is 1 over r squared, and the slope is capital G m1 m2, while the y-intercept is equal to 0. So now, in order to have a straight line, what I have to do is I have to keep the y-axis, or whatever the responding variable is, as not changed. I have to manipulate the or modify the manipulated variable into 1 over r squared, and then I will have a straight line that the slope is equal to capital G m1 m2. Does it make sense? Let's see now another example when you are doing an experiment in kinematics, let's suppose. So in kinematics, what we are doing, or what we are supposed that we are doing, is we are running an experiment where we are measuring the final velocity of an object, and by changing the distance in which the object is moving. And we are dealing with a frictionless surface. So as a surface in which you are running the experiment, mass that you are using is the same. Initial velocity is the same as well. So conditions are pretty much the same. If we are stating now which one is what, then what you are changing in this experiment is the displacement. So that will be the manipulated variable. What you are measuring is the final velocity. So this will be the responding variable. And all those ones, this group here, will be controlled variables. Those are variables that are quantities that are kept constant through the experiment. Okay. Now, when you have a situation like this in a question that we have seen in kinematics on physics 20, will be something like, what is the final velocity of an object if initial is 12 meters per second, and the object is moving with an acceleration and moving acceleration given 1.2 meters per second squared at a distance of 12 meters. So the formula that connects everything that we have here is V final squared is a kinematics formula, is equal to V initial squared plus 2AD. And on this formula, what do we have to do in terms of this formula to straighten it? We have to mirror it with mx plus b, which is the equation of the straight line. Now, what we are measuring is the final velocity. So this will be, or something like this, modified version of this will be on the horizontal, vertical axis, sorry. And what you are changing is the distance. So this or something like this. Modified version of this will be in the x-axis, and then the y-intercept will be whatever is free term, doesn't have any variable on it. When you see this relationship, you notice that that is the manipulated variable is to the power of 1. So we don't touch it. But what do we see here is that y now is not just vf, but is vf squared. So the in order to have a straight line, what do we have to do in terms of the horizontal axis? We have to keep it as it is, so will be d, because it is to the power of 1. And then y is now not just y, not just vf, but it is vf squared. And the equation of the line will be a straight line in which whatever the manipulated variable or modified manipulated variable is multiplied by will be the slope. So the slope will be 2 times a, and the y-intercept will be equals to v initial squared. So now in your formula sheet, you can take any formula that you see in the formula sheet and then say in a graph, will that look like a straight line? If yes, then say what is the slope and what is the y-intercept. If not, then how can you modify it so that will look like a straight line? And on that case, what will be the horizontal and vertical axis look like, and what is the slope and what is the y-intercept. So this probably will be something that you will benefit from. But if we take a look at, let's suppose at the Coulomb's force. So electrostatic force is KQ1 Q2 over R squared, very similar to the universal gravity force. So KQ1 Q2 times 1 over R squared. Now this one here will become our new horizontal. So then in the graph, we will have 1 over R squared to straighten it out, and we will see that the slope is k q1 q2, and the y-intercept is equal to 0. And if it is not in our experiment, then it's as a result of systematic error that is happening in our experiment. So as for you to practice on straightening the line, would be a good idea to take all of the equations that you see in the formula sheet and then say, if I'm doing an experiment in which, in order to solve and to find further information from the experiment, I have to use this formula. Will that look like a straight line? If yes, then fine. If not, then how can you modify it so it will look like a straight line? And on both cases, what is the slope and what is the y-intercept representing as a physical quantity? I hope that this makes sense, and we will do examples in class about this. Okay, this is in regards to straightening the line.